Fifth grade Ancient Math Lesson 6.3. Represent subtraction with different sized parts. I can represent the difference between fractions with different sized parts using a visual model. Spark your learning. Mark and his friends are putting on a play. Mark is in charge of the costumes. He measures each sleeve in one costume to be 3/4 yard long. Each sleeve should be only half a yard long. How much should each sleeve be shortened? Okay, so draw a visual model to represent how much each sleeve should be shortened. So he had it to be 3/4 yard long, right? But it should only be half a yard. Okay, so we're going to draw one box and we're going to break it into how many pieces for the first one? 4, right? So those are 1/4 size pieces. And they have 3/4 right now, right? So we'd have 3 of them. Okay. Then we're going to draw another box, and it should be broken into what? Half, right? Size pieces. Okay. And they only want it to be what? Half, right? So we'd have one colored in. So how much extra do we have from that 1/2 to that 3/4? 1/4, right? Because from here to here, we have 1/4 of a piece. Okay. So if I also did my equation and worked it out, right, guys? Okay. So we would do 3/4 minus 1/2, right? We need a common denominator. What is a common denominator? What is the least common multiple between 2 and 4? 4. So do we have to change this 3/4 at all? No. We can just simply write 3/4, right? Because it already has our least common multiple or our least common denominator, right? Okay. Now, the next one we do have to change because it does not have a 4 in the denominator. So how do I get from 2 to 4? So times 2. So what I do on the bottom, I do on the top. So this would be 2/4, right? Okay. So 3/4 minus 2/4 equals 1/4. So by how much should each sleeve be shortened? 1/4 of a yard. Bill understanding. Anderson and Joanne sold tickets for the play. Anderson sold 3/4 of the roll of tickets, and Joanne sold 1/6 of the roll of tickets. What is the difference between the fractions of the roll of tickets that Anderson and Joanne sold? So basically, what tells us if we're adding or subtracting? The difference, right? So we have 3/4 of the roll up here for Anderson. And then Joanne sold 1/6. And then they want to know the difference, right? Okay. So the yellow represents who? Anderson, right? Okay. And then the 1/6 represents Joanne. Okay. Now, clearly 1/12 or 1/4 and 1/6 do not have a common denominator, right? What is the common denominator between them? 12, right? Okay, so we need to figure out how many 1/12 pieces can go in here. Okay, so basically, let's go ahead and work this way real quick. So 3/4 minus 1/6. So we said our common denominator was 12, right? Okay. So I need to change both of them, right? Because neither one of them have a denominator of 12. So how do I get from 4 to 12? Times 3. What I do on the bottom, I do on the top. 3 times 3 is 9. How do I get from 6 to 12? Times 2. What I do on the bottom, I do on the top. 1 times 2 is 2. And then I'm going to subtract it out. 9 minus 2 is 7/12. Okay, So for every 1/4, how many 12s do I have? 3, right? Okay, so I finish this off, and then there'd be a 12th here, right? And then I need to break these into 3 parts, correct? Okay, so if I count them up, do I get 7 boxes left? 1, 2, 3, 4, 5, 6, 7. Is that right? Yeah. Okay. So who sold more tickets? So who did we say sold more tickets? Anderson. Because we said up here, this was the yellow was Anderson, right? And the blue was Joanne. So basically the yellow bar is longer than the blue bar, right? So the yellow bar of 3/4 is longer than the blue bar of 1/6. Use the fraction model in part A to draw fraction strips in the dashed box to solve the problem. What size fraction strips did you draw? So we did what? We did 12 size pieces, right? So 1/12 size pieces. Okay. So basically it takes 2 12 size pieces to make up 1/6, right? So 2 1/12 size pieces to equal 1/6, right? And 3 1/12, and you have to have that dash there, guys, in between it, because if you don't, then it would be what? Like 2 1/12, and that's not what we're trying to say, right? Okay. So it took 3 1/12 size pieces to equal 1/4, right? So basically, our common denominator was 12 because of the 4 size pieces and the 6. So what is the difference between the fractions of the roll of tickets that Anderson and Joanne sold? So we said 7/12, right? So 7/12 of the roll. Two boxes have the same number of play programs. On the first night of the play, Diana handed out 2/3 of a box. On the second night, she handed out 5/12 of the other box. On which night did Diana hand out more programs? How much more of a fractional part of a box did she hand out? Okay, so we have 2/3 of the one box, right? 5/12 of the other box, and they want to know which night did she hand out more programs, and then how much more fractional part did she hand out? Okay, so for the first box, okay, we are going to have to do what? We have to break it into thirds, right? And so she handed out how much the first box? 2, right? So we're going to color in 2 of our boxes. Okay, then on our next box of the second box, she handed out how much? 5/12, right? So we need to break it into how many parts? 12, right? Okay, and then these are 1/12 size pieces, right? And how many of those do we need to color in? 5. Okay, so basically our common denominator in this case is going to be what? 12, right? Okay, so what number goes on top, the 2/3 or the 5/12? The 2/3, right? Okay, because which one's bigger, guys? We're finding difference. So when you find difference, you always want the larger one on top, right? Okay, because you guys haven't learned how to go into negatives yet. Okay, so we want the 2/3, right? Based on our picture, our biggest part is the 2/3, right? So 2/3 minus what? 5/12. And actually, you guys don't have this much room on your paper, so just move it over here. Okay, so 2/3 minus 5/12. And we said our common denominator was going to be what? 12. So does the bottom one have to be changed? No, it is 12. Now the top one has to be 12 though, right? Okay, so how do I get from 3 to 12? Times 4. So what I do on the bottom, I do on the top. So 2 times 4 is 8. Okay, and then does that still work for us? 8/12 minus 5/12. Is 8/12 still larger than 5/12? Yes. So 8/12 minus 5/12 is 3/12. Now does that match up to me from where we quit coloring on the second box to where we finished coloring on the top box? Is there 3/12 difference in there? Yes, there is. Okay. So on which night did she hand out more programs? The first night or the second night? Okay. The first night. Because our bar model for 2/3 is longer than our bar model for 5/12. How much more of a fractional part of the box did she hand out? Okay, so basically we said 1/12, but is that simplified? I'm sorry, not 1/12, 3/12. So that equals 3 goes into both. So 3 goes into 3 one time, 3 goes into 12 4 times. So 1/4 of a box more. Okay, and then how does your visual model show this? So it shows that she still needed 3 more 12 to make up the difference, right? So the bar model. Time for understanding. Number 1, Maria is in charge of the scenery for the plate. She paints 11/12 of a board green or blue. If she paints half of the whole board blue, how much of the board that she paints is green? So we circled our information, underlined what we're looking for. Over here to the side, we drew our first box, which was 11/12. We colored in 11 of the 12. The next one was half, and we colored in half. Then we broke the other parts into 12 and matched up what was already used. Or what was colored but what wasn't used. And so we came up with 5/12 that way, and we also worked out an equation and came up with 5/12 that way. So our answer was 5/12 of the board is green. On your own, use structure. Greta and Tran have the lead roles in the play. Greta is on stage for 3/4 of the play. Tran is on stage for 2/3 of the play. What is the difference between the fractions of the play that Greta and Tran each spin on stage? Draw a visual model to represent the difference. So we did Greta with 3/4, we did Tran with 2/3. We found from our picture that 3/4 was larger than 2/3, so